Greetings and welcome to this demonstration of constructing and interpreting a 99% confidence interval for a single population proportion. The context for our example is the Hamilton ACO, and specifically we want to construct a confidence interval for the proportion of ACO beneficiaries that smoke. Recall that a confidence interval is comprised of three elements. The first is a point estimate, which we denote as P bar. The second element is the value of Z that corresponds to the level of confidence that we are trying to estimate the interval for. And the third component of the confidence interval is the standard error of the proportion, which in this case is going to be estimated by P bar times 1 minus P bar divided by the sample size. So let's extract the information from our data set. Specifically, in this example, we know that the sample proportion of beneficiaries that smoke is equal to 0.170, and we know that the sample size is equal to 3,185. We constructed P bar by taking the number of smokers, which is 540, divided by 3,185 in order to get the sample proportion. We can also compute the standard error fairly easily by taking the value of P bar, 0.170, times 1 minus 0.170, divided by 3,185. And that equals 0.0066. So the third part that we need to be able to identify for the purpose of constructing the interval estimate is the value of Z, which is coming from the standard normal distribution. Recall that the standard normal distribution represents the sampling distribution for P bar, the sample proportion, that particular statistic. And Z, of course, if you recall, will come over here. Z is a symmetric distribution that is bell-shaped, and for the purpose of confidence interval construction for a 99% confidence interval, we want to identify the values on the standard normal distribution such that there is 0.005 in each of the tails, noting that the sum of 0.005 plus 0.005 is 0.01, and 1 minus 0.01 corresponds to our 99% confidence level. To find the values on the standard normal distribution, we can use one of two methods. The first is that we can use a standard normal table in a textbook. We'll call that old school. The second is that we can use the function in Excel corresponding to the standard normal distribution to identify the value that corresponds to these particular thresholds. If we do that, we will find that our value is equal to 2.576. In particular, the lower value is minus 2.576, and the upper value is positive 2.576. So let's put these three things together for the purpose of estimating our lower and upper bounds. All right, so if we substitute this in, I'm going to start with lower bound. We're going to take P bar 0.170 minus 2.576 times our standard error, which is 0.0066, and from that we will obtain a value of 0.152. Our upper bound estimate in this case is going to be equal to 0.170 plus 2.576 times our standard error of 0.0066. When we solve that, we will find an upper bound value of 0.187. So what does this mean in terms of interpretation? What this is telling us is that we are 99% confident that the true underlying population proportion of smokers in the Hamilton ACO is between 0.152 and 0.187, or alternatively, we can express it as 15.2% to 18.7% of the population. Now, I want to make two additional notes here. The first is that if we were to change the confidence level from 99% to 95 or 90%, what would change? Specifically, we would change the value of z. And in particular, if we reduce the confidence level, we will have a smaller value of z and a narrower interval estimate. The other point that I want to emphasize is that we sometimes use interval estimates to make inferences about population parameters. Suppose, for example, that the national estimate for smoking in the Medicare population was 0.09. In this case, we can tell that our population is very different from the national average or proportion because 0.09 sits outside of the confidence interval that we have constructed for Hamilton ACO. This concludes our demonstration of estimating and interpreting a confidence interval for a single population proportion. Thank you.